All right, so welcome to Hello World. This week we're going to be exploring Node.js or just Node or Node.js. Different people call it different things. It's a server-side runtime that allows you to run JavaScript on a server or just locally. You can do a lot of different things with it. It's pretty cool. So we're going to talk about what it is. We're going to discuss Node.js is a asynchronous runtime. And so we're going to discuss what that means, how to use it, sort of understand the asynchronous mindset, because it is very different than how most people are used to thinking about programming. And then we're going to build a very, very simple Node.js server and set up NPM and all the dependencies that you'll need for the future to run Node projects. So with that, let's go ahead and get started. If you do have any questions, feel free to put them in the chat. All right, so what is Node.js? It's a JavaScript runtime for your local machine. So what I mean by this is if you've used Python before, or if you've used C before, you can run those programs just on your local command line, right? So in the example of C, you might run gcc to compile your C into assembly code that your computer can run, right? And then you can just run that binary. If you know Python, you can just use the Python interpreter directly on the command line, or in your IDE, click the run button, and you'll just be able to run that. With JavaScript, as we've kind of seen in past workshops, basically the only place we've seen it run is in a web browser. So you have to either open up your browser console, right? So that's one way you can do it, open your browser console and run things. You can have a web page that loads in some JavaScript, right? That's one thing you can do. What if you just want to actually run Node on the command line? Like what if you want to write a program you might traditionally write in C or Python or Java or C# or any number of other languages, and you just want to run that locally on your machine? Well, there never really was a way to do that because JavaScript was originally invented to be used in your browser. So Node.js is a way that you can do that. And we're going to get into exactly how it does that, all the details of what it really is and why it is so cool. But here's some other basic facts about it you might want to know. It's built originally by this guy named Ryan Dahl. Awesome guy. This was really revolutionary when it came out. I believe it came out it was about 10 years ago. I think it was either 2012. It's either 2008 or 2012. And at the time, people were kind of skeptical of it, but it's really taken over in a lot of places because people love to run JavaScript, both in their browser and on the backend as well. It uses Chromium's V8 JavaScript engine. So if you use Google Chrome or use Chromium or some other browser that's based on Chromium, Microsoft Edge is now based on Chromium. Most browsers that aren't like Firefox or Safari are based on Chromium. So, okay, so we have someone in the chat saying it came out in 2009. Awesome. Thank you for that correction. So yeah, if you use any version of Chromium, right, in order for your JavaScript to run, it runs inside of a JavaScript engine. And this JavaScript engine for any Chromium-based browser is called V8. Google develops it. You can see its logo there on the page. It's really an awesome piece of software, and it runs JavaScript pretty fast, all things considered. So what our guy Ryan Dahl did here is he took that V8 engine and he added some code to plug into your local file system and other things that you might need for a server or a local runtime. And then together that makes up Node.js. So don't think that he just like completely wrote all of this himself. He did use a lot of existing tools and libraries, but really the idea was awesome. Okay, so I know I talked about a server, like, hey, you want to take this, you want to have a server where you run your Node. You can use Node to host a server, right? But what even is a server? Like, why would you want to do this? What is a server? What can you use it for? Well, a server is basically just a computer who talks to other computers. So if you've ever set up like a Minecraft server or something, maybe you've run that in your computer before. What you're doing is configuring your computer to accept output or accept input from other computers and talk to each other. And so all web pages are being hosted by a server, right? Every time you go to google.com or youtube.com or netflix.com or whatever site you want to go to, there's a server that is sending you back the content that's supposed to be on your page. So servers are very important. Anytime we were talking about the cloud, so Google Drive or iCloud or any cloud storage, that's just a server. It's just some computer sitting most likely in a data center somewhere, well air conditioned and everything, just sitting there, that listening to your requests and sending you back the information you request from it. And it doesn't necessarily have to be. A lot of times when people think of service, they think, oh, I need a big building with awesome air conditioning and a bunch of machines all plugged in, or like some kind of supercomputer. Like you can run a server on your own hardware. That's actually what we're going to do today. It's going to be, now we're probably not going to leave this server up. It's not going to be like a super powerful server that you'd want to run tens and thousands of requests at. But for simple things, you can run your own server. It's very easy to actually. You also hear people call this the back end. So if the front end is kind of what we've been doing for the last couple of weeks is front end JavaScript. So like your HTML, your CSS, and your JavaScript that you're displaying in the browser, that's all stuff that's on the front end. It comes from the server originally, but it's code that runs ultimately on the client. So that's referred to as your front end, and then your server is back end. And why do we need those? We'll kind of see that in a minute here. So, okay, here's a diagram that I have used several times in a couple of different of these hello world things. You basically, the way the internet works, you have clients and servers. So clients, that's your computer that you're using. So your phone, it could be an iPad, it could be your laptop, it could be your desktop, that's a client. Your server, that's the computer sitting in the data center, or it could be something you run yourself, but most people do not really run servers on a regular basis. And they're connected through the internet. So the reason you'd want to have some code run on the front end and some code run on the back end is there are certain things that you really do not want to be sending out to everyone. So let's talk about a bank application, right? So say you have an account at a bank online somewhere and you want to sign into your account. Well, to implement sign in, we need to take in a username and password. So we might have some input fields like we sort of did last week with the weather application we wrote. So they type in those things, you'd read them. How are you going to verify that those credentials are correct, right? Well, you could do it on the client, but in order for that to be possible, then you would need to have all of the usernames and all of the passwords on the client. And not only is that a huge security problem because anyone could just go to the website and see the whole database of all the different usernames and passwords, that'd be horrible, right? There's also the problem at some point, like that could be a lot of data. It could take a very long time to send. So you don't really want to be always sending everything you have to the client. So this is when a server starts to become something you want to do. So instead what you can do is just send the basic login page. You're sending, on the client, how do I render my, all the images, the text boxes, all of that stuff. Anything related to showing just that basic login page, you send that to the client, which is much smaller. And then once the client puts in their login information, you send that back over the internet to the server, which you control. And there you store all the usernames and passwords. And then you can check manually yourself if it's correct. And if it's correct, now you can send a more privileged page. So you can say, okay, these credentials match this specific John Smith. And so I'm going to send back all of John Smith's financial information to that client and only that client. And this works because now your server can have all your secure data, all data that you don't want just anyone to be able to read. And so that's why it's important to have servers and not just clients, not just client-side code. You want to have some server-side or back-end code as well. There are some instances in which you can get away with mostly just a front-end approach. So if you have a site that's just like a personal, like a site that only serves up like public information, then you might do very well to have your server basically only just send front-end code and doesn't really do anything itself. And that's fine. But there are many applications where, like, banking, any kind of shopping application, anytime you have account authentication, any of that stuff, you're going to want to have some kind of backend that can keep all of those credentials secure. All right, so that's basically what Node is. If anyone's confused about that, go ahead and put a message in the chat. But Node is just a way to run JavaScript on the server side to do those sorts of password validation things and all that sort of stuff. What's special about, now these servers have existed for a long time. So even before Node, you had servers, right? The internet was around before 2009. Somehow people got all this stuff done. Well, so one thing that's different about the back end compared to the front end. On the front end, you basically have the HTML, CSS, and JavaScript stack. There's not really any, that's what you use in the browser. Nothing else is really supported. Sometimes you have other languages that can compile into JavaScript but ultimately you're going to be shipping HTML, CSS, and JavaScript. On the back end though, you can run basically any programming language you want. So if you've ever heard Java is a big language for the back end, Python can be used on the back end. Basically any language can be used on the back end. And before this, that's basically how things worked. So one that was really popular, like PHP, if you've heard of that, PHP used to be a huge backend language. Ruby on Rails, huge backend language. Those were things that were extremely popular on the backend, and that was one way to do things. We have a comment in the chat. I heard PHP is gross. Yeah, I've never personally learned it, but I know a little bit about it, and there are reasons why. It's very dynamic. It actually shows a lot of characteristics with kind of early JavaScript in that way. But yeah, there's a reason it's becoming less popular over time. So that's what you used to do. You used to have these sort of languages on the back end, and then you'd run your HTML, CSS, and JavaScript on the front end, and like that was fine. The other thing you would do is there was basically no concept of this asynchronous IO. So everything would be synchronous. And what that means is, so your page would make a request and get the initial page back from PHP, say. Okay, so you get your HTML, CSS, and JavaScript page from PHP, render that into the browser, and then if the user clicks something, then it would, what would have to happen is the browser would send a request back to the server, and the server, every time someone sent a request, the server would spawn off a new thread. Because your server doesn't really want to only be able to respond to one person at a time, right? That might be okay if you have a small site, but if you're doing anything at scale, you're probably going to have, at least at sometimes, multiple people trying to make a request at the same time. So in order to deal with this, well, your computer has multiple cores, right? Most computers do. So if you have like a dual core or a 4-core or a quad core, 6-core, 8-core, right? You might have X number of cores. Well, the server also has some cores. And so each one of those can kind of be doing its own thing at its own time. So what you would do is every time someone made a request, you fork off a new thread, and a thread is just something that can run on its own. And so that way you could have, for each request, you could have its own thread. All those can run in parallel, or at least up to how many cores you had. And that was how you would do things. The problem, this actually led to a big problem though, because there were some websites, like top websites. So we're talking about, like Google, Wikipedia, huge websites that are serving tens of thousands or hundreds of thousands of requests at a time. And what was actually happening is these sites simply couldn't handle forking off that many threads, because every time you make a new thread, it does require some amount of memory. And what was happening is these machines were just getting bogged down because they just couldn't handle how many requests that were being made. It was too inefficient to every time someone made a request, fork off a new thread, handle the request, and then kill that thread, and then fork off a new thread. But if you're doing this tens of thousands of times per second, you need a very powerful server to do this, and it was very inefficient. And so if you ever heard of like an Apache server, this is fundamentally what Apache does by default. Apache will fork and make a new thread every time you get a request. And so these companies were like, okay, we can't really afford to do this anymore. There has to be a better way to do this. So there's actually another server application that was created, and it was called Nginx. Have you ever seen, here, I'll put it in the chat because it's spelled. I probably should have made a slide for this, but if you've ever seen that before, you pronounce it Nginx. And this took a different approach to things. Instead of forking off a new thread for every single one, it would only keep a few threads around, and it would just do everything in an asynchronous way, an asynchronous non-blocking way. And this was a lot more efficient and allowed these companies to do this massive scaling. Okay, so this was sort of a new idea at the time. Nginx, I don't remember exactly when it was created, but this was kind of a solution to that sort of problem. People were using Nginx. Most sites still used Apache, but huge sites, top sites, often use Nginx as it was more efficient. And so you had this going on. And this is sort of where the inspiration for Node.js came out of. Because at the time, most languages, you would use Nginx to serve all those requests like that, but your language itself would still sort of use a blocking IO model. And so what Node.js is that makes it different from any other server backend language is at the beginning, it only had asynchronous calls. And you see this little footnote here, Node has added synchronous calls. So you'll see that there do exist synchronous calls, but most tutorials you'll see, and kind of the standard way to do things in Node, is async. So let's talk about what async exactly is and why you want to do this. So synchronous IO is basically, you can think of it like a phone call. right? So if I call you right now and we actually want to get communication done, we both have to be on the phone at the same time, right? So I call you, right? It might ring for a few seconds. And while it's ringing, I just kind of have to wait. Like I can't really do anything else because you might pick up at any second. So I'm going to wait. Then eventually you'll pick up, hopefully, and then we'll be able to talk. But in order for us to talk, we both need to be actively listening at the same time. Now, this isn't necessarily a horrible thing as long as we're both very good about picking up the phone. But a lot of times this isn't the case. Like, for example, I don't know about you, but my experience with customer service in many cases has been, in many different places, has been less than optimal. I've been on hold for half an hour or an hour waiting to talk from a customer service. And this I find very inefficient. I don't like doing this, right? No one wants to sit on the phone all day waiting for someone to pick up. In some cases, maybe they'll never pick up. You don't really know. Sometimes it feels like that. So that's Synchronous IO. You can see that kind of has a downside because unless both parties can respond at a relatively instantaneous frequency, there's going to be some time wasted. Async IO is a different model. So Async IO is a lot more like an email or a text. So if I want to email customer service, I can send an email saying, hey, I need help with this. But I don't have to wait for them to come back and send me an email. I don't have to sit there at my computer and stare at my inbox for hours or days waiting for them to reply. I can leave and come back whenever I want. I can send it and forget. You don't have to wait for the other side to reply to you. You can just keep going on with your day and then come back to it when you have time. And the other nice thing about this is if they never reply, then it's not a big problem. Well, I mean, it is a problem in that if I was trying to contact customer service, I never got customer service. But it's better than me just sitting on the phone for hours and hours and hours, never getting a reply. At least I saved all that time. So that's sort of one metaphor you can think of, difference between synchronous and asynchronous IO. Synchronous IO, both the parties have to be talking at the same time and they're waiting on each other. Whereas async, you can kind of fire off a request for something, and then when it comes back, you can deal with it. And if it never comes back, you don't have to deal with it. Here's another sort of model of how you can think about async. So async's a lot like how I do my chores, right? So if I have to do some laundry, the first thing I'll do is I'll put the load of laundry and soap into the washer, right? And I'll start the washer. Now, if I was doing this in a synchronous way, it'd be pretty terrible because what I would do is put that load of laundry in the washer and then sit and wait for the washer to finish, right? Just stand there in front of the washer, waiting. Eventually it'd finish, right? Then I can move it over to the dryer. Then I wait, and then boom, my laundry would be done. But this is, hopefully none of you does this. It's a very inefficient way to get laundry done, right? Most of us, what we would do is put our laundry into the washer and set a timer or a reminder or something or whatever. And then we would leave, come back later, right? So maybe I go get something to eat, I go work on my homework, I do other things, whatever. And then at some point, the washer will stop, right? Or I'll get that notification on my phone. I'll get some reminder. And what's interesting about async is you don't have to immediately go do that. So you don't have to, just because the washer stops, right? I don't know about you guys, but usually when the washer stops or the dryer stops, I don't immediately drop everything I'm doing to go deal with the laundry. I might go ahead and finish the problem I'm working on or finish whatever I'm eating, right? You can finish what you're doing to be more efficient and then get back to that as soon as you can. So I go back to the laundry, right? I move it over to the dryer. Then I can go back to my homework, work on that again. When the dryer finishes, again, I don't have to immediately go to it. I can leave it for 5 minutes or 10 minutes or however long until I finish what I'm working on. And then laundry done. So that's kind of an async model of doing things. You can see how if you're anytime you're spending a lot of time waiting for things to happen, it can be inefficient. And async is a way to get around that limitation. Okay. So let's take a look at what this actually looks like in code. So we're looking at JavaScript. This is adapted from our official Node docs. You have some different differences. The language is the same, but you have differences in the APIs that are available to you. So as we saw kind of last week, some of the APIs you have available in the browser are things like document.querySelector, right? To grab DOM nodes or grab references into your HTML. So you have that sort of ability. You have a fetch you can use to asynchronously request data. Well, Node, you have different APIs. So in Node, you have file system APIs. So in the browser, you can't really go like read from the file system. It's not designed for that. That's just not an API that's available. In Node, you can. And the way you import things in Node is a little different as well. So if you've used if you use front-end JavaScript, usually you see like an import statement. If you've seen that in JavaScript, Node was actually invented before that was invented. So there used to be no import in JavaScript. And Node was like, we have to have a way to import things. So they created this require function where you do require and then a string, and then it gives you back the module or library you're trying to import. And then at some point after require had become pretty standard in Node, you had the import added in ES6 for JavaScript. And so front-end JavaScript traditionally uses import, and Node uses require because they had this, it was working. Why would they switch it? And so you'll see usually that's usually a good sign. If you see require, you're probably looking at Node or stuff that's designed to run on the command line. So that's another difference that you see between the languages. Kind of unfortunate, but most of the core language is the same, right? We have our const, we have our console.log, which does a similar sort of thing. So let's take a look at this synchronous versus asynchronous example of reading a file. So both of them are going to import this FS module. That's your file system module. That's how you actually interact with the file system. Now our first example is a sync example. So we do fs.readFileSync. And notice this is how you can kind of start to see that synchronous is not the default in Node. So if you just do read file as in our second example here, everything by default is going to be async. Most of the time, if you want a synchronous version, you need to append a sync to whatever it's called or pass an extra argument or something. Usually async is the default. So in our first example here, we're going to do read file sync. You do the file name, UTF-8, that's our format. And then this is what's called a blocking call. So we're going to wait. So we're going to wait for the disk. Basically what this will do, spin up the disk. Or if you have a solid state, then you won't spin up the disk. But say you have a hard drive, right? It spins up your disk. We're going to wait for that data to be read from the disk. And then we'll eventually get it back. It'll be stored into data. While we're waiting for that data to show up from the disk, we can't do anything else because JavaScript is only single threaded. So unlike in Ruby on Rails or PHP, you just can't spawn a new thread. There's just no way to do it. So if you have multiple cores, JavaScript can't really take advantage of that. It just doesn't know how. It can only do one thing at a time. So that's why this is kind of a bad way to do things, because while we're reading this file, reading a file, for example, might not take that long, especially if it's just a text file. But if you have like a 1 GB file, a video file, some big file, it could take a while. Or maybe you're doing other kinds of I/O, like if you're doing a network request, right? Reading something over the network takes, for computers, even if it takes like a second, that's a really long amount of time that a lot of stuff could have been processed on your CPU because it just works at on such a much faster time scale. So reading things synchronously is usually considered like a wasteful way to do things. But this is how you do that. And this is kind of probably what you're used to. If you've used like scanf in C, where most of the time you have most languages by default, you kind of get introduced in a blocking way. So you learn the synchronous way to do things. And that is the default in most languages, where you call a function and that function will block. It's not going to execute anymore until that data arrives. And it's just one way of doing things, I'm not trying to say sync is always the wrong way to do things and async is always the best. There's trade-offs both ways. But most languages kind of support synchronous programming as the standard, and async is something that's more unique to Node. So we get back that data, right? On line 3 here, we log out the data, then we log out hello. And my comments here kind of show what you get out of that. So we would get whatever the data in the file was. That's what that's supposed to represent. And then when we get hello, just how you'd expect, that's fairly sort of a simple program. Now let's look at the asynchronous example. This one trips people up a lot. So the difference with async is, remember, we can't wait for the file to read, because if we do that, we might waste time, right? If it's a huge file, that could take a long time. We don't want to do that. So we do things in a slightly different way. Instead of waiting for the data to show up and storing it in a variable, we tell the fs.readFile function, hey, when our data shows up, we're going to give you a function or a block of code that we want you to run if and when this data shows up, right? So if you look, the first two arguments are the same. We've got this, the file name, character encoding, and then you have this error, comma, data, arrow looking thing, right? If you were here last week, you might recognize this. This is an anonymous function, another thing that many languages don't have great support for. But basically, it's just a block of code that takes two parameters, and then if you look what it does, it logs it out. All right, so what we're saying is, we know that this read file could take some time. So instead of waiting for it to happen, we're just going to say, hey, read file, when the data shows up, here's what you should do with it. In the meantime, we're going to continue on our merry way. All right. So we say read file, when that data shows up, do this. But for now, we're just going to keep going. So great. We dispatch read file to go spin up the disk, start reading hundreds of megabytes of video or whatever. And then we go down here to this console.log hello, and we log that out. So if you actually look at what this will output, every time you're going to get it in the opposite order you might sort of expect. First, we're going to see hello logged out. And then when the data gets read out of the disk and this function gets invoked with that data, you're going to get the data coming out second. So it's kind of that backwards order that kinds of sometimes trips people up. But yet what you have to remember about async functions is anytime you're calling a function in an asynchronous way, it's not whatever you're currently working on is going to finish before that function gets called. On the other hand, this is more efficient. So there's that. So let's take that's sort of like the simple example, how it works. Now let's delve into how this is actually happening under the hood. This slide here sort of shows you, here's what happens when you do this, but how does this actually work? So if you're curious about how this actually works, this is a great diagram I found online on Stack Overflow. Some random user put it up. But so here's how Node.js works. And this also applies to the browser as well. So if you're using any asynchronous APIs in the browser, which most of them are, there are very few blocking APIs in the browser. So if you use like fetch, for example, which we used last week, any type of network request, all those things are going to be asynchronous. It works in a very similar way. I'll kind of explain that as well. So let's say we have our client, right? So here's our client. This is your browser somewhere. They're going to do a fetch. They're going to invoke, do an HTTP request to your server. Okay, so great. That's these arrows coming down here. And then we have this event loop. So the way JavaScript actually does what's going on here, how does it know what order to execute this in? How does this all end up working out? At its core, you have to understand that JavaScript is basically just a C++ program. Okay, let me say that again. JavaScript is just a C++ program. It's just a C++ program that knows how to read a text file and then interpret it as JavaScript. So it checks for the ifs and it checks the condition and decides what to do, right? Every programming language has to be written in a programming language. So in JavaScript's case, every browser is written in C++ because C++ is very fast and we want JavaScript to be at least somewhat fast. So JavaScript is written in C++. So your V8 engine, for example, is written in C++. Chrome is written in C++. Firefox is written in C++. So you have that. And C++ is the one who's actually kind of enabling JavaScript to do this, because this isn't something, this idea of asynchronous programming doesn't really exist without C++ kind of providing the abstraction. So what the way C++, here's what C++ is doing. So C++ is having this event loop run in JavaScript. What your event loop does is first it runs your main JavaScript file. So they're going to send us a request. And let's say our JavaScript file is this first synchronous example here, right? So it's going to just execute this line by line. So it's going to import the thing, going to read the file, wait for it to show up. It's going to log the data and log hello, and then it'll be done. But whenever your current file finishes running, you go into what's called the event loop. So see with this event loop, this loop here that says single thread, your event loop continues to process as long as there might be new events that show up. And so this is how these asynchronous APIs work. So let's look at our second example here. We import, same thing happens, right? So we get this, we want to read in a file, right? So we import our module, then we do this read file. Now what is inside this fs.read file? Well, fs.read file, actually inside of it is going to have that function. Parts of it are going to call into that native C++. So C++ is giving us our bridge to the file system and all of that stuff. That's what Dahl wrote into Node.js. That's what makes it different from your browser. Your browser doesn't give you that stuff. Node does give you that stuff. And that's all inside of this fs.read file. And what happens when you actually call this is that C++ kicks up a thread. Okay, so you see this little long running jobs run on worker threads. So the way this actually works is you see this now internal C++ thread pool. C++ has a bunch of threads that are just waiting for these things to happen, right? Because any number of files might need to be read at the same time. So I think by default, Node has like 4 threads that are just always waiting around for stuff that needs to be done. And so anytime you call an async function, what's really happening is that job is getting shunted off here to another thread that can run in parallel in C++. And C++ reads the file. Now, JavaScript, right? JavaScript doesn't know about this because it's inside of the C++. So JavaScript's just like, okay, whatever, that function is done. C++ is doing its thing. I don't really care. And JavaScript is able to keep going, right? So that function call to just the async read file, fs.read file here, it immediately finishes, right? This is almost instantaneous. It just passes these arguments in, and then it goes straight to C++ doing things. And JavaScript's like, okay, that's done. So then JavaScript keeps going and says console.log hello, logs out hello. And now we're just sitting in this event loop with nothing to do. Now this event loop keeps like spinning, you can think, right? It's always checking to see, has anything else shown up to happen yet? Does any other code need to be run? Now eventually C++ will finish doing this file read, right? This thread here in the background is going to actually read the file from the file system or fail to find it or whatever. And either, regardless of success or failure, it's going to add that function back into the JavaScript event loop. So this callback function, this error, data, console.log data, that will magically reappear to the JavaScript interpreter at some point. And these get queued up. So remember, JavaScript only does one thing at a time. So it gets added to some queue, like I think of a queue is just a line. So if you've been in line for like a roller coaster or something, if a bunch of files are trying to all get read, they'll all get stacked up into a big line. And then JavaScript, when it's done running that main file and it's just kind of spinning in the event loop, is checking that queue to see, have any new callbacks or any new of those functions, have any of my previous asynchronous requests finished? And if it finds something on the queue, it'll pop the top element off the queue, run all of that code, and then go back to the event loop. So it'll read one file. So in this case, we only have just the one thing, right? We read the one file, and then console.log data, we're going to log out what was in that file. Great. But if you had multiple file reads, then what would happen is you'd have multiple C++ threads reading these things. And then they would all, whenever they finished, they would get pushed in this queue, and then the JavaScript event loop would read them off one at a time and print the things out. Okay, so I know that's highly, and then, okay, the very last thing in this diagram here is then you might, in this case, we're just reading a file, so it doesn't really match to this. But if this was as a result of some client request, then at that point, we might eventually send back the request to the client. So if you have any questions about that, that is like, it's important to understand this because a lot of the consequences of the things that happen, there are some unintuitive things that will happen sometimes in JavaScript when you're doing asynchronous stuff. But if you really understand that this is how it works, it's basically just everything's running inside of C++. And whenever you do IO, it's just getting shoved off to a C++ thread. And JavaScript just keeps doing one thing at a time. Then you'll kind of understand what's going on. So that's a great diagram. I love this diagram. Fantastic job to this user 568109 on stackoverflow.com. This is basically how Node works. And this is really interesting compared to how the reason this is more efficient than doing it in other ways is we, instead of spinning up tens of thousands of threads, we can keep just 8 or 9 threads around and just have those threads constantly be picking up more information. or new requests. So instead, because we can't, if we have 10,000 threads all trying to read a file at the same time, or read different files at the same time, that can't actually happen, right? At most, we can take advantage of, 8, 16, 32 threads. And so if we just keep that many threads, the maximum that we can actually handle, and have all those running, and then have, because the other thing that happens is there's another queue. So there's kind of a queue between the event loop and our non-blocking workers. So I think by default, Node has 4 non-blocking workers. So if you try to do 5 IO events at the same time, 4 of them will run and the other one will wait in the queue. And then when one of those 4 finishes, that thread will pick up another one from the queue. And this way, we can avoid a ridiculous explosion of threads because we have tens of thousands of requests coming in, and all the memory pressure that's going to result because of that. And so that's why this ends up being more efficient in cases where you have so many requests. Okay, so that was a callback style API. Everything is built on top of this. So this function here, this third parameter that's just a function taking error and data and then logging it out, that is called a callback, because what will happen is C++ will like call you back when it has that data. So that's what the idea of a callback is. It's a function you pass in that's going to get called once the IO operation finishes. Now, some people looked at callbacks, and callback APIs do have some problems. Like you have something called the callback pyramid of doom. Here, let me see if I can find a picture of that. Callback pyramid of doom. Okay. And what will end up happening, here's a good example, is if you have a bunch of these callbacks, like say you need to read one thing, and then based on the results of that, read another thing, and then based on the results of that, read another thing, you can get this horrible pyramid structure where things just keep shifting further right and further right. And there are meaner names for it as well. But people were like, okay, this maybe isn't exactly what we always want in this callback API. So what they invented was this thing called promises. And a promise it's a very thin abstraction around callbacks. It's just it lets you think about them in a different way, but it works in fundamentally the same way. And what's different about it is instead of immediately passing in the callback of what you want to do, by default, the function will return you an object that represents the pending result. So kind of ignore this .then and all this stuff after it, right? If you just call fs.readFile, so this looks a lot like the synchronous one, but it's not. If you just call fs.readFile, you get back a promise object that sort of represents that eventually the data is going to show up. So it's a promise that that data will show up someday, hopefully. I mean, it can be broken, so maybe promise. I don't like promise. I think future is a better word for it, but it's a promise that the data is going to show up for you someday. And then that promise has a method on it that knows how to take in callbacks that you want to invoke when that happens. And in this case, it doesn't really look a lot different than the callback API. We just have this .then. But when this is useful is if, say, you want to do an IO request and then return the results of that to whoever called you. So you might have, if you're trying to do like functional decomposition and you don't want to have all these callbacks being passed around, what you can do is make a request, get back a promise, and then return that promise from your function, and then let your caller attach callbacks to you instead of trying to like pass in the callback into the read file. And this also kind of reduces the nesting problems because you really only nest once because you can just keep doing chaining more .thens. And so that's kind of better in that way as well. So, but basically it works in the exact same way. It's just a sort of another way to think about and represent callbacks and asynchronous IO. You'll see this is mainly, so you'll still see in Node, you'll see a lot of callback APIs. A lot of people still use the callback style ones in Node because that was sort of the original one. In the browser, you see that everything is promise based. So if you do a fetch, you don't get callbacks. You get a promise back. And many other languages also have some concept of a promise or a future. They sometimes call it different things, but it's the same idea. You get back this object that you can then chain .then or something similar and pass a function. That's what you want to do. So you see this in a lot of different languages. But yeah, it's basically the same thing as callbacks. Just the syntax is going to be slightly different. And so you can see it sort of does the same thing. So we read this file, then we register this callback when we get the data. And then remember, this is going off to C++ land. And then JavaScript logs out hello, C++ gets back to us and pushes this callback onto that queue. The event loop picks this callback off the queue and actually calls it, and we print out our data. There you go, promises. The last syntax you will see, because people were like, hey, promises, kind of messy. They still wanted to make this even better. You see this thing called async await. And there's sort of two parts to async await. You have async functions, which I'll talk about in a minute, and you have await. So a lot of people think this is somehow blocking or something. It sort of behaves kind of like it's blocking, but it's literally just, it compiles away to promises. Okay. So it's still promises, which are really just callbacks. It's all callbacks. It's all built on top of callbacks. It's just syntax sugar. Just another, some would say, nicer way to express what a promise is. And so the way this works is you can put this keyword await in front of a promise. So here's our fs.read file, right? So this top example is just our promise example from before. This bottom is our async await. So we have this fs.read file, and that gives us the promise, right? But what you can do, instead of chaining .then onto it, like we have in our top example, and then passing a callback, you can instead just say we're going to await that value. But it's not actually waiting, okay? Don't think it's actually waiting. It's doing the same thing that's happening up here. All that event loop stuff, all that calling out to C++ land, all that stuff is still happening. It just looks, you can think of it like it's happening synchronously, which is why people like this, because they don't have to really think as asynchronous of a way. So you put this await keyword in front, and then magically this await fs.read file that's going to give you back the data. And then you can just use that data is no longer in a promise. Like that data is actually like the real data. You can use it. You can just log it out. Now you can start to see the abstraction sort of leaking when you see, okay, we have to wrap this all in this async function. What is this? Well, so here's the catch with await. If you could do this on the top level, like if you could just await things straight away on the top level, then what you basically are doing async IO, right? Let's go back to our synchronous example. Where was that? I think I went by it. Yeah. Okay. So it looks a lot like this top example, synchronous example here, except we don't have the await keyword. But this is actually what this does. It will wait for that data to show up. Await isn't actually waiting. Okay. So when you do await, what it really does is it's just another. You can think of it as just a different way to write this whole .then callback nonsense. So when we await fs.read file, what it's really doing is .then, error, and then data, and then another function. And the reason you can sort of see this happening is you can only use await inside of an async function. You can't just use await on its own, because if you were able to just use await on its own, then you're basically just doing synchronous IO, which is not really something that's allowed or that people want you to do in Node. And so what is this async function? Well, very simply, an async function is just a function that returns a promise. Okay, so you can write your own async functions. You just put async function, and then, or you don't even need the async keyword. You can just put function, and then if you return a promise from your function, it is an async function. You can use it just like one. If you instead put async in front of your function, then that function, even if you return like say we have an async function that just returns 5. What it actually returns is a promise of 5. Okay, so all async function is, an async function is just a function that always returns a promise. And because it always returns a promise, then anytime you do await, it's just chaining .then into that promise. That promise is containing that .then. And so that's why people expect this to it looks like it's synchronous, but it still is doing all the same stuff that the promises are doing, which is just doing the same stuff that the callback is doing. It's all still asynchronous. And so if you look at how this ends up running, it ends up running the same way. So we have this async function. And because what's going to happen is, as we call this async function, so if you're not familiar with this syntax, it might look kind of strange to you. But this is, if you just want to define a function and then immediately call it. And the only reason we're doing this is because we want to call this async function. So we have these parentheses. So this open parenthesis is closed below here on this line 1, 2, 3 on line 5. So we have this we're just defining an async function. And then the two parentheses and colon, we're just immediately, or semicolon, immediately calling that function. So we're just making a function and then immediately calling it. The only reason we're doing this is to wrap it in this async so we can use await. So when this happens, what's actually happening? Well, first, okay, we go to this first line here with const data. Well, we can't do that until we evaluate the right side. So go to the right side, fs.read file. So this is going to return us a promise. And then when we see the await keyword, it's going to chain that dot then. And then it knows from the left side that the variable needs to be called data. And then the rest of the async function is just going to be wrapped inside of that dot then. And if you await multiple times, then what it's equivalent to is a bunch of nested dot thens. And so we do that, but remember, as soon as we stop to await this fs.read file, what's really happening is that's getting shunted out of C++. We're going to print our hello, so that's why hello gets printed. And then eventually C++ will get back to us. It'll put that onto the queue into the event loop. We have nothing else to do after hello, so we'll go and pull that off the queue, run it, we'll have our data, and then log it out. Okay. Question. So we have a question. Would you be able to use the async keyword with an arrow function? Yes, you can. You can. I just write it this way because I don't know. I know people from last week probably are familiar with arrow functions. But yeah, you can just, it just works the same way. You just put async and then you do normal arrow function. Okay. So that's async await. If you see that, just know it's actually promises, which is actually callbacks. It's all the same stuff. All right, let's talk. So that's all the async stuff. If you're confused at all about anything that's async, that's something that's very, very core to Node, very core to JavaScript. And in order to what I've been trying to do for the last couple of weeks is sort of prepare you for our upcoming Mern Stack workshop. So yes, okay. Someone says go back to the previous slide for 1 second. Yeah. So if you're confused about any of this stuff, this is stuff that's like Dylan's likely going to use in that Mern Stack workshop, because there's just you can't do network requests in Node or JavaScript without using promises or async await or something like that. So yeah, take a look at this, soak it in. If it doesn't make sense immediately and like you're not really sure what questions to ask, but it still doesn't really make sense, like just know it might take some time for it to sink in. Why is there parentheses around async? Oh, yeah, so you don't actually need those parentheses. You can drop the parentheses around the async function, but it's just standard practice to do that to make it less confusing so that people know you're doing, so when you do this thing where you make a anonymous function like this and then immediately call it, it's called an immediately invoked function expression. That's the official name. And so whenever you do it, good style is to do it like this so that people know that's what you're doing, because otherwise it can look like a function definition or something. People get confused. So yeah, that's all that's going on there. You don't actually, I think, technically need those, but I've never seen anyone not do it that way. So that's the way you should do it. Okay, so that's all the async stuff. Now we're going to talk about NPM and like sort of some more practical things about Node that are going to be useful. So NPM is just your Node package manager. So Node people were like, hey, we want to have libraries. We want to be able to use other people's code, because if someone else has already written the code you've written, why are you rewriting? You're just wasting time, right? Someone else already made a great program that knows how to draw a square in JavaScript. Like, why would you re-implement drawing a square? Just use theirs if it's good. So to solve this, right, we have the Node package manager that gives us kind of a unified way to install other people's libraries and useful functions and things they wrote. It was originally just sort of a Node thing, so that it's obviously the Node package manager. But the front end JavaScript people who didn't have import and they were kind of behind in this sense. Were like, hey, we really wish we had a package manager too. So they're just like, hey, you know what? Why don't we just use Node's package manager as well? So a lot of front end projects you'll see also use NPM. It's basically, you can really just think of it at this point as the JavaScript package manager, but it does technically stand for Node package manager. And okay, one thing you should know about this, if you're cloning, like doing a git clone or downloading a project that is managed with NPM, most likely you're going to need to run npm install to actually get all of the dependencies. And the reason for this is it would be kind of pointless for GitHub to store like let's say there's a library that draws a square, right? And it's lots of lines of code. Say it's 1,000 lines of code or whatever. Do we really need to store those thousands lines of the 1,000 lines of code for every single project that ever draws a square and have a separate copy of that in every single person's GitHub? Probably not, right? That's really just wasteful. So instead, the way Node actually works, or NPM actually works, is you have a file, a text file that just describes these are all the things that we need for this project, and that's what you upload to GitHub. And then as soon as you download the project, you run npm install, it reads that file and actually installs the files that you need. And that way our hosting services, because these Node, if you've ever seen a Node modules folder, that's where npm install installs to, and they can get pretty heavy for big projects because big projects have a lot of different dependencies. So yeah, if you're ever trying to run a project that you just cloned that's using npm, you probably should run npm install first. Okay, so with that, now we're going to actually go and install Node, install npm. It's all like one package. So if you already have that installed, then great. If not, I'm going to show you how to do it. I'm on Mac, but the process for Windows is going to look very similar. All right, so step one, Google Node.js, or just go to nodejs.org here. And conveniently on the front page, you will find downloads. If not, you can go to this downloads section here. And then you'll probably get some options. So you can either do LTS, which is, I think, long-term support, or you can get current. I always run current because I like getting the latest features, and I find it plenty stable, but some people recommend you get LTS because technically it'd be more stable and more tested or whatever. But I don't know, I would get current. So I would go to current and then just grab the appropriate installer. So if you're on Windows, you grab this one. I'm on Mac, so I'll grab this one. And then just install it. If you just walk through the installer from there. So I think, let's see. Yep, so we'll install this, continue. I already have it installed, so I'm not going to actually go and do this again, but you can install that. On Windows, you're going to see a similar installer. You just walk through directions. Does anyone want me to walk through it on Windows? I can fire up my VM and walk through it on Windows if you want. It's a pretty straightforward install from what I remember. No? Okay. All right. Great. So yeah, if anyone does want that, like I'm totally happy to do it, walk you through, because installing can sometimes be one of the hardest things, hardest parts of programming. So yeah, I'm happy to walk through it. But if everyone is good with walking through those installers or already has it installed, then I'm not going to waste time on it. Okay. Then let's write a hello world server. Actually, let's see, what time is it? Yeah. Okay. So yeah, I want to wrap things up here. So we're going to write a very simple server using Node. And kind of, we'll also see the event-based architecture. So let's see. Let's pull up. Let's get a new window here. Okay, great. So if you want to follow along here, then you can just open up whatever your favorite text editor is, and you'll probably need file manager, whatever your file manager is as well. So let's make a directory for our project. So I don't know, Node project, and then go ahead and open up that directory. All right. So once you're in this directory, if you want, you can like do git init and start a git project, or npm init. You can do. We probably should do an npm init. So if you want to actually create a Node project, you just need to run npm init in a directory. And it'll ask you for a bunch of things. So project name, you can name it what you want, but I'll just stick with the default version. If you want to set a version, you can. Description, I'll just leave it blank. Most of the stuff you can leave blank. Entry point, index.js, that's fine with me. Test command, you just leave it blank. Git repository, just leave it blank, unless you have one. Keywords, what keywords does is if you want to publish your project, like if you write a useful library that you think other people might want, and you want to publish it to npm, you can. And then the keywords are like, if people search for things, so maybe you write, your square drawing library that's so great, then you could put like square and drawing in the keywords. So when people search for that, your library will come up. But yeah, we don't care about that. Author, you can put yourself if you want. License, in this case, license, you probably should. I have a great workshop on software licensing that we did last semester that's recorded on YouTube if you want to watch that. But I'm not going to get into it now because we're not going to publish this or anything like that. So, okay. And so this is what's going to write. You notice it's kind of in the format of a JavaScript object. So it's in your JSON, standard JSON format. It's going to write this. Is this okay? Yep, we're happy. Okay. Oh, new version of NPM. Okay, well, maybe later. All right, so now if we look at what it's given us here, so we have all we have is this package.json, okay? And we have this test that doesn't do anything and a lot of empty fields. All right, so our main file is going to be index.js. So let's make an index.js file. And we're going to set up a very simple HTTP server. So to do that in Node, first you need to require the HTTP module. So make a variable to contain that. And then remember in Node, we don't use import or anything. We use require. So we require HTTP. And that will import the module for us. Okay, great. So we have that. Then we need to set a listener. So you can declare this in a couple ways. So the way I'm just following on with the official Node docs here, but this is probably like a more confusing way to do it than you could. You can also use an arrow function. In fact, let's do that just for. Okay, so make this request listener. You can also do, you know what? I'll do it this way, because this will look most familiar to most people probably. Okay, so we're going to declare a function that is our request listener. So this is our callback that's going to get invoked every time someone makes a request to the server. And we're taking two parameters: this request parameter (req) and this res, that's our response. And so by manipulating those, we can read the data that has been sent to us by the request, and then we can manipulate what we want to send back. So that's great. In this case, we're not really going to do a whole lot here. Just for this example, just to see how you can sort of read what URL was requested, I'm going to pull out the URL. So if you actually go to request.url and pull out that into a variable, you don't even have to pull it to a variable, but I'm going to. That's going to be the URL that they requested, like relative to your server. And then to send back a response, we just do response.end. So you can also set lots of other properties on it. I'm not going to get into this again because you'd usually use like express or something like this to make it a little simpler. So this is just going to be a very simple app, but we're going to send back something. You know what? For our first iteration, let's just send back hello world, for a good hello world program. So we don't care. We're going to ignore the request completely and just send back hello world. And that's great. But this function doesn't call itself, right? We have to actually set it up to be called. So how do we do that? Well, first we need to set up a server. To set up our server, we just do http.create server. And then you pass in the callback that you want to be called when your server gets a request. So we're passing the request listener. And then you also have to tell the server what port to listen on. So again, I'm not going to get into this because this is stuff that can be configured, but for most part, port 8080 is a good one to use. That's kind of your standard default. Okay, so now this is our hello world node program. So yeah, 9 lines. Okay, so how do we actually use this? Well, first we have to actually run the service. How do you do that? You just run node and name your JavaScript file. Okay, so right now node is going around in the event loop. So what actually happened when we do that? All right, so it imports the thing, it defines this function, it makes a server, and then it sets the server up to listen, right? And then at the end of this, after it finishes line 9, the event loop is just spinning, waiting for requests. Okay, so that's why the program doesn't end, because we have things that are waiting. So we're just going to kind of sit here. It's spinning around in that event loop, waiting for C++ to tell it, to pop some requests onto the stack, because C++ does all the real work. And so, okay, how do we actually send a request to this? Well, we can go to, what was the command again? Just node and then the file.js. So if you call it something other than index, which you can, but that's just sort of the default. So just node and then whatever the name of the file is. By the way, you can also use this just to run like general, let's say if we just want to do like an actual hello world just on the command line. So this is something that's not really has anything to do with Node, but you can use Node to write command line apps. So if you just want to run JavaScript on the command line, don't use your browser, then you can do the same thing without using any of the Node APIs and just do like a simple hello world sort of program. Can you show the file one more time? Yes. Okay. Here's your file. You don't need this line. That's just going to be like sort of something. Just that was that. I'll show you that in a minute. This is all you really need. If you want to get fancy, you could also people who were at my last workshop know that you don't need to. If you're just going to define a function, then immediately pass it to something. You could also use an anonymous function for that. But I'm not going to do that right now. Okay. So we have this. Is everyone good? All right, I'm seeing no complaints. So, wrong file name. Okay, so we're running the server. It's spinning around the event loop, right? Think back to that slide. It's just waiting. It's waiting on C++ to feed it some requests. So let's give it a request. So how do you do that? Well, you can see. I guess it doesn't show. Sometimes. So if you use a framework, it will like give you the URL. It's very nice. But by default, it's just going to set up on localhost. So if you're actually setting up a real Node server to like be open to the internet, then when people go to the URL, which will be translated to an IP address, that'll be the IP address of your computer. But in this case, since we're just running it locally, then localhost is how you interact with your local server. So if we just go to localhost :8080, then we should get to our server. And there we go. We see it sent us back hello world. You can also send back other things other than plain text like JSON and such, but we're not going to do that today. We're going to keep it simple. We're already kind of running a little later than I wanted to go. Okay, so we sent back hello world, and just to see like sort of one thing you can do. So if you want to, oh, by the way, it's Control-C. If you don't know, that's how you like stop it from running. That's how you force quit it. So let's say we want to actually like pay attention to the request, right? So if we want to see, because in this case, we totally ignore the request, but you can grab information from the request and then do different things based on what that data is. So in this case, instead of printing hello world, let's grab the URL it sees and then print that, send that back instead, just to see something a little different. All right, and so what this does is if you do an extent, so if we just do this, it's going to just give us back a basic slash. Because really, the page we're actually visiting is this page. But if you put something here, like let's say we do, we send hello, then it will give us /hello. So you can see what path they requested. And if you go to like a search engine, like let's go to Google, right? And you search for, you'll see, okay, you see all this stuff up here in the URL that's added? This is all data that's going to, it doesn't necessarily have to be a Node server, but it's going to Google's server, and they're parsing this to figure out exactly what you requested and decide what to send you back. So yeah, that's how all that stuff works. And we're not going to get into detail with that. I want to go ahead and wrap things up in case people have to go. I want this to be a shorter workshop. So yeah, are there any questions about any of that stuff? You can of course do you can do a lot more stuff, but I don't want to show you too much Node stuff because likely Dylan will just be using Express, which it's a wrapper around this and it gets harder to do things. Okay, is this not till 9:30? Yeah, so technically we usually block till 9:30 in case we want to run for 2 hours, but I've been trying to make them a little bit shorter, more digestible. So yeah, I wanted to keep today short. Next week we will be doing React.js. So React.js, basically, so what we're trying to learn is the Mern Stack, sort of the components, so that when we do the Mern Stack workshop, you can see the whole thing together. And so your Mern Stack is just a technology. If you hear about like these technology stacks, right? It's just a bunch of technologies you use together to do something cool. So the Mern Stack is just MongoDB, which that's just a database. I'm probably not going to go over that. That's pretty simple to use. Express. So Express is that's sort of it's a wraparound Node's APIs that makes it easier to handle the stuff. And then React. So we're going to talk about React next week. React is a front end library for building reactive user interfaces. declarative, component-based, learn once, write anywhere, you know, has great stuff. But that's next week. So yeah, if there's any questions about Node.js, that's basically all the main thing I wanted you to take away from today is the async, the idea of thinking in async. Yeah, can we see the code again? For sure. Oh.